In this demo, I'm going to show you how to take a look at a sine graph and read some of the characteristics from that graph. Characteristics such as period, amplitude, vertical shift, and get that information directly from the graph. So let's just take a look at a few examples and see what you can do. In this particular graph, we're going to learn how to read the period of the function. There's a couple of ways you can get the period, so I'll just show you two different ways. If you're lucky enough, the x-axis will be marked and you can read directly where there's webbing. So as long as you're reading where the sinusoidal function is doing the same thing at the webbing, then you are fine. I'm outside, so you can probably hear traffic going by. So in this particular graph, if you look right, let me see if I get a pen. You can look right here. You've got the same thing going on in your function at pi and pi over 2. So you could use those two values to find your period, and you wouldn't have to do any additional calculations. You could just use that subtraction. You could say pi over 1 minus pi over 2 and get a common denominator. So here we're going to have 2 pi over 2 minus pi over 2. I'm going to run out of room. And we're going to get 2 pi minus pi, and you're going to get pi over 2. All right, so our period is pi over 2. However, in most cases, you're going to use max to max because that's actually what you see the most often. You see most textbooks and any online lectures you see, they say use max to max, which that's fine too. I usually just look for webbing or where it's just the most convenient for me, just because that's the way I do it. But often it's not already marked. So what you have to do is you have to figure out what that value is right there. So in order to do that, you need to figure out what your units are down here at these hash marks. So that's not too much trouble. You just need to figure out what you're marked off in. And you do that by finding your first marked off value and divide that by how many units you've been marked off in. So in this case, you've been marked off in 1, 2, 3, 4 values. Okay, so you're at pi over 2 after 4 values. So you take your pi over 2, and I'm just going to come over here where I've got some room. Pi over 2, and you're going to divide by 4. Okay, so if I divide that by 4, then I'm at pi over 2 divided by 4 means I'm multiplying by pi over 2. I'm going to multiply, that's 4 over 1, I'm going to multiply by 1 over 4, which means I'm at pi over 8 units. So every mark is pi over 8. So then I can just say pi over 8, and if I add another one, I'm at 2 pi over 8, 3 pi over 8. I'm just adding a pi over 8 at every one. So this is actually 4 pi over 8, which reduces to pi over 2 conveniently, 5 pi over 8, and I just keep going, 6 pi over 8. So this makes this 7 pi over 8. So if I come right here, this is 3 pi over 8. So now I know what both of my peaks are, and I can do that arithmetic. So I'm going to have 7 pi over 8 minus 3 pi over 8, which gives me 4 pi over 8, and that reduces to pi over 2, which is the same thing I got earlier conveniently. So either way you want to do it works out just fine. Okay, next characteristic is amplitude of the sinusoidal function. That just tells us how big our curve is, how far does it stretch. That can either be done with a formula or you can eyeball it, either one. I like a formula, that way I'm sure of everything. Sometimes my eyes deceive me. Easy formula here, it's max minus the min divided by 2. But this one just goes from positive 3 down to negative 5. So if I've got my positive 3 and down to my negative 5, I'm going to say positive 3 minus negative 5 divided by 2. So that's going to be 8 divided by 2, super complicated math here. So I have amplitude of 4. And if you want to add that up, you can see that this goes 4 units up, and down here we've got a total of 8 units here, or 3 units up, sorry, 5 units down. So you've got 3 here, 5 here. So you're good to go there. On the next one, you want vertical shift. How much do we shift off of the x-axis? How much do we move up and down? Now the standard sinusoidal function just goes nowhere off of the x-axis. It just stays right through the x-axis. The center of it is at 0, and in this case, this one doesn't shift at all. This one is just right through the middle, so we just go through 0, so the middle of it is at 0, so we say the vertical shift of this one is 0. Mathematically, if you want to calculate that, you take the highest point and the lowest point and you add them together and you divide by 2. So you take your max plus your min, in this case, not minus, and you divide by 2. So if you took 2 plus negative 2 and divide by 2, you're going to get 0 divided by 2, which is 0. Conveniently, that equals our vertical shift. Okay, so this one's asking you to find the period, again, of the function. I'm going to show you something a little different on this one. Remember, your sinusoidal function is just your unit circle. It's just your curve going around your unit circle. So all of these marks are the same thing as radians and degrees. So if you like working in degrees a little bit better than radians, which I do, remember that 2 pi is the same thing as 360 degrees, and pi is 180 degrees. So here you'd be sitting at 60 degrees, and here you'd be at 120 degrees, and here you'd be at 240, and here you'd be at 300. So you've kind of gotten out of radians and now you're in degrees, which is a little bit maybe easier to work with in your mind. So here we've got your max is at 300 degrees here, and this peak would be at 60 degrees. So we could calculate our period using 300 and 60. So all you need to do is do that subtraction and then calculate your period. So if you do that, you're going to have 300 minus 60, and you're going to have 240 as your period. Now, IXL wants you to put that into radians, which you know how to do. 240 over 1 times pi over 180 equals, you're going to just convert, you're going to end up with, you're going to reduce, of course, you're going to end up with 4 pi over 3. So there is your period for that curve. Now, if you were going to keep it in radians the whole time, remember you need to divide this to figure out what your units are, because we're not going through webbing. We're going through 1, 2, 3 units here. So we've got pi over 3. I'll put this in another color. We're going to work through pi over 3 right here. 2 pi over 3 here. So this one is at pi over 3, which if you remember on your unit circle, pi over 3 is at 60. That's convenient. 2 pi over 3, 3 pi over 3, 4 pi over 3 right here, 5 pi over 3 right here. So here we're at 5 pi over 3. So do that subtraction. 5 pi over 3 minus pi over 3, and you have, voila, 4 pi over 3. All works out to be the same thing, just depends on what you like to work with, degrees or radians. All right, one more period problem. Now this one is pretty well set up. We have the peaks going right through webbing, which is nice. Right here we go through at 2 pi, and here we go through at negative pi. So we can just subtract those and get the period very, very fast. So we're going to have 2 pi minus negative pi. 3 pi is the period for this particular function. And we're done with that one. Wouldn't it be great if they were all that quick? All right, vertical shift. So vertical shift is how far, I'll just just jot this down. How far the midline is from x-axis. Okay, so you can just eyeball the midline, and in this case we're going to see that it's at 3. We can see that. So how far is that value from the x-axis? It is up 3. So the vertical shift on this particular function is positive 3. Okay, now if you want to calculate that, you would take your max and your min and you would add them together. So you would say 6 plus 0 and divide by 2. 6 divided by 2 is 3. So it works out like that. Last example is another period problem. So let's see here. We don't have any webbing doing the same thing at the same time where it's ready to go for you. So let's calculate the unit. And in this case, we are going through at 1, 2, 3, 4, 5, 6. So we're going to take pi over 2 and we're going to divide by 6. So that's going to be pi over 12. If you're not sure where I got that, it's pi over 2 times 1 over 6, which is pi over 12. So each one of these is pi over 12. Okay? So 2 pi over 12, 3 pi over 12. So let's call that 3 pi. And I know that reduces, but I'm just going to leave it like that because I'm lazy. All right, so 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12. So now I have two values that I can subtract. So 7 pi over 12 minus 3 pi over 12. So I'm going to have 4 pi over 12, which reduces to pi over 3. There's the period of that function.